Yeah, Kris Kowal from Agoric. Welcome. How are you doing?
Well, thank you, and pleasure to be here.
Where are you joining me from?
The San Francisco Bay Area, as the cliche demands.
Not necessarily. It's becoming less and less. My wife is actually there right now covering the electric boat racing competition or something random. I don't know.
So why am I here and not an electric race?
Full-size boats, not like toy boats, like full-size ones.
Yeah. My father trafficked in full-size steam automobiles and steam boats as well. So I know the esoterics are available.
Now, we've already tested this and it didn't really work properly, but I think it's too nice to not show. But you actually have the ratio is wrong, but you actually have a chinchilla. Most people don't even know what the name means, let alone have one. So tell me about this 20-year-old chinchilla. What's its name?
Yeah. My wife has had Chinchilla for many years now. She adopted him from a friend in college who couldn't care for quite so many pets anymore. And he's from Canada. And he emigrated. Well, she adopted him while she was in college in New York at Cornell, and then crossed the country in a car with him, and he got to see all of the United States.
So are we going back to Latin America? Damn. Yeah. It's a very old nickname I've had. It's a very old nickname I had, and I actually once played in a band with a Mexican, and he, of course, pronounced it correctly as well, which is Chinchilla.
Yeah. Probably Chinchilla. Chinchilla, I would imagine. South America.
He'd been living in Australia for a long time, so he's also not completely accurate. All right, enough about chinchillas. So you're a software engineer for Agoric. It's actually been some time since I've had someone from a blockchain parallel company on. But we'll dig into that in a bit more. But give me your kind of pitch of what Agoric is and what you're doing.
Yeah, Agoric is building a level 1 blockchain that runs JavaScript as its primary language. And the idea is to provide access to the bulk of programmers who already know JavaScript so that they can write programs that transit the boundary between the chain and on-chain, have a single language for your DApp, your front end, your back end, and seamless communication among them. And our chain is built on Cosmos, on Tendermint, and supports IBC, the inter-blockchain protocol. So the idea is that you'll be able to wrap assets from other chains and write contracts for them in JavaScript.
So let's just unpack one bit of jargon there that might be important to know for some people. What does level 1 mean?
It means it's like central, like useful for clearing. I think all of the chains that we know about, for the most part, are L1 chains. The exceptions would be rollups or such like that. Like Ethereum, for example, and Bitcoin are both L1. Okay.
And I feel like you're not the only project that's tried this. I feel like even a company that's just down the road from me has actually did anyway, something similar like Lisk, and maybe a handful of others. Are you aware of others who are trying or have tried something like this?
Personally, I'm coming to Agoric from JavaScript, less from blockchain. What's appealing to me about Agoric is that I get to work with some of the pioneers in the field of electronic computing and who have been active in the JavaScript ecosystem for as long as I have, and we are not just a blockchain. I like to think that if crypto winter comes, a lot of the technology that I'm building will still be relevant because you can run the same. The same system that does contracts on our chain could be used for consensus in with data center scoped consensus and be just as valuable. This non-deterministic JavaScript running parallel in multiple machines for purposes of auditing or just reliability is still relevant. And so like a lot of the technologies that we're building is based off of ideas from that our founders conceived of 30 years ago, before blockchains had been conceived of. And they were members of the cypherpunk movement and were really interested in getting cryptography and making the world we live in, basically. And it's really great to see from the inside a company that's taking a whole bunch of unrealized ideas and bringing them to the real world once and for all.
So let's get two origin stories, and then we'll dig into some details. What was the origin story of the company? You mentioned some of these founders, but why start this, and what problem were they trying to solve at the time?
Yeah, our founders, Dean Tribble and Mark Miller, our chief scientist, and Brian Warner, our director of engineering, our economist Bill Tulla, they all have known each other for many, many years. And Mark and Dean invented promise pipelining when they were at Xerox PARC, I believe.
Ah, okay. Another thing from Xerox.
Yeah, Mark also invented what's called Miller columns when he was at Xerox, and that was borrowed by Next and borrowed by, therefore, OS 10. So if you go into the Finder in OS 10 and see column view, that was Mark's invention as well. But not for that purpose. He was building it as a distributed graph visualization. So you could just poke through not just directed graphs like you can in a Finder, but you could actually just visit arbitrary graphs, just dig deeper and deeper in the path through a graph. But yeah, they invented promise pipelining, which is a concept that which builds on the idea of promises, which they also brought to JavaScript.
Yep.
And previously brought that to technologies. Dean brought it to technologies at Microsoft, like the Midori operating system, which was based off of object capabilities, the same concepts that we're building on. And Brian had worked on projects going back to Twisted. He made a thing called Magic Wormhole for cryptographically sending things between computers. Yep. It's just large peer-to-peer file router, essentially. Yep. And so they've been interested in this concept of object capability programming and bringing it to bear for many, many years. Okay. Another one of our engineers, Chip Morningstar, is probably best known for having implemented JSON. He was he worked with Doug Crockford. They were partners at a startup when they created JSON. Doug Crockford named Mark Miller's programming language E. It's a thick web of connections going many, many years back at this company.
And what brought you into it then, apart from some of those names?
Yeah. Very good question. I sometimes wonder how it happened myself. I had been around 2006 trying to build a module system for JavaScript. That module system eventually became CommonJS and became the module system that Node uses. Yep. And I had, a couple of years before Node came around, I had pitched the idea to randomly to the Google Kaha mailing list, and it turned out that's where Mark was working. As I was looking for people who were willing to join me in trying to get a sort of ad hoc standards movement around writing portable JavaScript, so that we could ditch the framework specific module systems at the time. And so I had spoken to like Hannes Wallnefer in Austria he was building a server side JavaScript engine called Helma NG, and there were a few other people who were interested, but we hadn't gotten any traction until I met Mark through Google Kaha when I was leaving Apple, and he said, well, let's talk. We met, and then they weren't able to do anything with it in their project but they remembered me, and a year later, Mark invited me to speak to TC39, the group that builds the standard for JavaScript. And so I pitched it there, and then I pitched it to CommonJS. And around the same time, Mark said, you really ought to check out promises. Maybe we can get promises into the language too. So I built a library called Q, which eventually served as the prototype for promises in the language. And it was also based entirely on Mark Miller's work and also some precedent from another engineer named Tyler Close, with whom has been in our community a long time. Yeah, that's my story. That's how I found Agoric.
This is a very senior team. I mean, I have hung around the blockchain space for a while, and there's a lot of young people. This is a very senior team for a company that is in this space. What has attracted all of you to the concept of running JavaScript on the blockchain? I guess, like, why?
I think
a lot of older engineers seem to be quite skeptical of blockchain. Actually,
for sure. What brings us to JavaScript actually is like, you tend to think two things about JavaScript, right? When it comes to security, like, one, why? Some people seem to think it's the least secure programming language there is. But on the other hand, it's also the one programming language we trust to run arbitrary programs from strangers on the internet all day, every day. So there's something to it.
Like, well, if you would trust someone with a lot of your security, they're going to have some security problems sometimes.
Yeah. I mean, and the reason for that, I think, is because JavaScript was designed in a time where viruses were rising. It was becoming a concern. People were suddenly having to care about running arbitrary programs off of the internet, bricking their machine or making Windows move against their will, et cetera, et cetera. And so it was born from that. It really needed a language that could solve this problem. And it, over time, I mean, it still protects your file system. It still protects your compute and all of these things. What it doesn't protect you from is it was born in a time when you could trust that there was a single tenant in your web page, that you only had to trust one entity, and now you have to trust many entities in most web pages. And that's where the security starts to they start to lock down and bring us closer to the same origin policy, draw us back into trusting only one party. And it's a delusion, really. You need to be able to trust multiple parties. You need to be able to arrange contracts of a sort between multiple parties on the web. You need to be able to say, hey, I need you to be able to render over here, and I need you to be able to I need to be able to enter a credit card number here without this chat window or without these surveillance cookie things being able to see all of your interactions. And so when Doug Crockford was at Yahoo, he built a thing called AdSafe, which was an idea to write a JavaScript subset that was based off of the notion of object capabilities. Object capabilities are this programming paradigm where you're like, hey, you already know how to write secure programs. It's called encapsulation, and object-oriented principles work for you. So it's like, how do we make secure programming accessible to people who just came out of college? Well, the answer is object capabilities. And you just need to have a language that supports object capabilities in order to do that. And the first idea for that was to use a JavaScript subset. And then, but that required having to recompile your code and do some server-side analysis of the program to make sure that it wasn't leaving its object capability boundary. And to be clear, object capability means that if I give you an object to act that provides a file system API, that is me giving you permission to use the file system API. And as long as you have a programming language that enforces that the only way to get a handle to an object is to having been expressly given it, then you have object capabilities, and you can use common patterns like dependency injection and things like that to make arrangements that limit what other people can do, and trust them all in the same memory of the same process, which with Spectre and Meltdown, which we'll see in this demo I'm about to provide, if you're trying to protect against that, you have to live in a pretty rigid container. But there are more uses depending on how you arrange your process boundaries. If you can use the same arrangements using remote objects. You can do object capability programming where you have a reference that's stretched cryptographically to another program, and have the same arrangement. Hey, you have file system access. It's asynchronous. It was always asynchronous, but now it's asynchronous because it's in another process as well. So things like that. So Doug Crockford knew Mark, and they said, hey, Mark, you wrote this programming language that's built for object capabilities called E. No one's ever going to use it. You know what they will use? They'll use JavaScript.
Yep.
Which
it's
is
it's all starting to sound. Sorry, it's all starting to sound very. You've dropped a few words and concepts and technologies that all start to add up to why you're with Agoric, I think.
Indeed.
And actually makes me think a little bit of WASM as well, WebAssembly, which is also very popular in the blockchain world, maybe for similar reasons. But now I think you have something you want to show. I must admit, I'm not 100% sure what kind of demo you're going to show. So let's just go for it and see what happens. I'll bring you.
I think this is right down your alley and down the alley of your audience. Brian Warner, one of our engineers, many years ago, built this hardened JavaScript escape room. So the bottom layer of our technology is hardened JavaScript, which builds up JavaScript to be that object capability language we talked about. Okay. And that means that all of the primordials and all of the intrinsics and their prototypes are frozen and immutable in this container. And that's what allows us to say the only way to get something is to be given that thing. So it doesn't just lock down the intrinsics. It also creates this thing called a compartment. And the compartment is an evaluation container that shares all of the intrinsics, like array prototype, with the surrounding environment, but is limited. It has a limited global object, right? So I can say, hey, you program, I'm going to give you access to these specific capabilities, which are hardened and attenuated and revocable. But they're just JavaScript objects. I'm going to introduce them to you in some way or another in this compartment. And my proposition to you is that you cannot escape that compartment. I can run any program you write in that compartment, that smart contract, for example, running on a chain, and you will not be able to escape, right? Yeah, and more so on the chain, that you will not be able to do anything that has non-deterministic behavior, because we need to run the same program all over the world and settle on the same snapshot of the results. So what this program does is it's a challenge to you, to everyone. Please come break our thing. We have arranged a program that has a secret code inside of it in its own memory, and it has created a compartment where it will run your program. And let me scroll down to the bottom. Your program will go right here. And it'll be the form of a generator function that our program will call to accept your guesses for what the secret is. Right? And I propose that if we deny you access to timers and just run any program here. So let me just give you this example. I'm going to guess this 10-digit string. I believe it's 10. And I'm going to run that program, and it's going to propose the guess, and it's read. I was wrong. And here are some sample other programs, like, what if I tried all zeros? Nope, I guessed wrong again. Okay, well, what if I wrote a program? Well, let me first enable. I'm going to give you access to date.now. And date.now is a coarse resolution timer, but for the purposes of giving you a chance to win at this, we have contrived a poorly written program that gives a hint to the user about whether they guessed correctly or close to correctly through a timing channel, which is basically how attacks like Spectre and Meltdown work. If I were to give you that date.now function, and if you were to write a program like this that checks how long it took you to answer my question about whether it was the correct guess or not, by building out this code and then measuring how much time elapses while you're checking. And if I were to execute, and you'll note that guess is running on your stack, so it's going to block while it's checking your guess for an amount of time. If I run this program, I can gradually, like the cliche, like war games style password cracker, eventually figure out what the guess is. Right? So this is a program that escapes, and it escapes because we have given the program access to date.now. Now, if I instead provide date.now that does not give you that, you can use the same timing side channel attack forever without getting any closer to victory. And my proposition to you, my challenge to you, is to write a program that goes in this box that I can press execute on and eventually discover the password that's hidden behind the curtain.
So I guess so you give people this option to enable date.now, but I suppose this is just for the example. By default, you probably wouldn't, or it's up to you, I suppose. Whatever you want. The
idea is that by default, hardened JavaScript and our shim for this feature, which is standards track. It's two things. Hardened JavaScript is this lockdown feature. It's also the compartment feature. The compartment feature is JavaScript's missing module loader API, something that we've needed for like a decade. We'll get around to it. And this is our intention of getting the compartment API so that you can do module loading. But just for the purposes of hardened JavaScript, the compartment, like the function constructor and other evaluators, gets attenuated. Its abilities get limited, so that you can provide these security guarantees inside of the compartment. And by default, it provides no access to timers. It provides no access to shared pseudo-random number generators. So math random, for example, which is a covert side channel. So we deny those things. Yeah. You can give them back. You can provide a date that lies. You can provide a random number generator that is like if you wanted to give one guest, you could create your own PRNG implementation, seed it cryptographically, and then give it to two different guests, and they wouldn't be able to use it as a side channel and still have the random API. But at the very base layer, we make the best decisions for providing containment above all else and determinism above all else. And then you can gradually endow these compartments with further capabilities if that fits your attack model, right? And then you can give it access to file system APIs that don't necessarily give access to the entire file system, that interrogate the user whether you actually want to allow the program to have access to things, that kind of thing, which is, very consistent with the web's APIs in general. And the major difference is that things that are shared between guests are transitively frozen so that they can't be tampered with.
So just to relate this back to Agoric, so let's cast aside, well, maybe it's part of it, I'm not sure. So if someone likes what they're hearing here and thinks, I need this for whatever purpose, and I understand why hardened JavaScript if you're running smart contracts on a blockchain makes a lot of sense, because you're probably doing financial transactions of some description, or you want provable transactions of some description.
Yes.
But how do I quote unquote get this? Like, is it a package, a framework, a JavaScript fork? Like, what is it?
So there's a package on NPM called SES. And you download that, you call lockdown, you construct a compartment, and you go to the races. And you can do that on the web. You can do it in Node. Strangely, a lot of packages in the NPM ecosystem work on this because it's just a general good practice not to monkey around with the prototypes. to attack the prototypes. A small number of packages do. Some packages actually need to, but most of them are avoidable if you're trying to write something that runs in this environment. So it's basically an acceptable cost that some packages don't work. But yeah, you can get arbitrary things off of NPM. There's another part of our architecture called the compartment mapper, which basically provides Node's module system, an emulation of Node's module system, so that it can build up bundles, it can find packages off of that have been installed in your Node modules tree, and then provide a compartment for all of your third-party dependencies. So another value proposition beyond the chain for hardened JavaScript is isolation of third-party modules. And so, like, lockdown, for one, just like it protects you against this class of attacks called supply chain attacks to a limited extent. For one, prototype pollution attacks will not work if you're in a locked down system. Those also won't work if you use the frozen intrinsics flag in Node. Mm-hmm. But lockdown provides the same feature for the web and also gets around some other nasty things you don't want to worry about for web compatibility. On top, so if you give all of your third-party packages separate compartments, that means that you can endow them with limited powers, right? So our friends at MetaMask use this, and they use it to protect their system online in the Chrome extension and other browser extensions, and they also use it to secure their build toolchain, and then they also use Docker containers and stuff like that in order to limit their build.
And this starts to tie things together, doesn't it? This is something that I've definitely seen in and outside of the blockchain space, this aspect of installing packages and dependencies that are what they say they are. And it makes a lot of sense, especially for something like MetaMask, which you're also, as a user, entrusting quite a lot to. So MetaMask for non-crypto people is a browser extension that gives you basically a wallet in the browser, wallet interface to do various things with.
A payment system, basically, for web pages.
I also noticed, I'm half Australian, and I noticed you have RMIT, Royal Melbourne Institute of Technology, as a user client as well. What were they doing with Agoric?
Yeah, our friends at RMIT are building. They work with our founder and economist Bill Tulla, and they're working on the economy of our chain. And our chain is a 2-token system. There's a stable coin called Run, and a permissions coin called Build, essentially. There's a governance token called Build. And so the folks at RMIT are responsible for, well, not responsible for, but they help us craft our economy and the parameters around our economy and designing the systems that ensure the stability of the stable coin, the value of the governance token and such.
Okay. That's with their blockchain lab, I guess, or if that's still a thing they have. I don't know.
It's very antipodal from here in many ways.
We're rapidly running out of time. It's kind of a fascinating conversation. We didn't really get too much into the details of the company, really. But what are people building? What are some of your users doing with this, whatever components that may be at the moment?
Yeah. So we are on our way to launching so we have our mainnet 0 is out, which is to say that the Cosmos layer of our chain is live. And the next milestone for us is to launch permissioned JavaScript. Which is to say that the contracts that are running on we will begin running JavaScript contracts on our chain. They will initially be the ones that are agreed upon, I believe, by governance. This is not my part of the stack, to be clear, but I think that the idea is that we will release a version of the chain where we have limited contracts, and then eventually we'll get, and then the next milestone or two, we get full permissionless contracts where arbitrary contracts are not even granted by governance, just published and pay the fees, and they'll run with metering and all of the protections around that.
Yeah. Yeah, it's kind of, this gets quite interesting. Unfortunately, we're running out of time, but my mind is running to all sorts of potential, quite interesting use cases here. And I like the fact you've got something that, yeah, in theory, I suppose you could swap out the back end and carry on using some of the same principles and technologies. You'd have to replace some concepts, some technological concepts that you get with a blockchain that you might not get with MySQL or something. But
I mean, if you were building on Paxos or any other append-only log, all of our technology would run on top of that without much modification at all.
Could you have a Git backend? Maybe.
I think that,
in theory,
I mean, the answer is, of course, yes. It's just a matter of
why I thought that, but yeah. Why you'd want to, I don't know, but yes, I get that.
Yeah, that's true.
I get the principle.
Yeah, and so to answer your earlier question more directly, what we are aiming for is for people to build building blocks.
Yep.
In this earliest phase. The idea is that you only need to write an auction contract once. You don't need to copy and paste somebody else's auction contract. You can literally use it to build a building block in your contract.
And then you can have like a hardened equivalent of NPM modules.
Yes, exactly.
Yep. Okay, cool. All right. I think that's
We're expecting that kind of combinatoric and exploiting. In fact, literally putting these contracts on NPM. And then composing new contracts. Like all of our material is also on NPM.
Yeah.
And it's on our chains technology is all open source. It's all on GitHub. It's all on NPM.
I think that's an interesting nugget to leave as a final thought. So I can see. I usually ask people what's next on the roadmap. You've already mentioned it a little bit. I can see here. Yeah, Q2.
We're hiring. That's on the road.
Hiring and mainnet. It looks like you aim to have all the mainnet in place by the end of the year, basically. And then, so maybe we'll talk in a year's time and see where things have got to. So, cool.
If experience serves, we will go from nobody. This massive shift from people tinkering around with blockchain to everyone, right? We'll have a massive ecosystem of building blocks and components.
That's a whole other conversation, which I don't know if I want to have right now. All right. Thank you very much, Kris. Thanks for your time. Thanks for the trip down memory lane. Thanks for the trip into the future. Thanks very much for your time. Take care.
Thank you.